The second lab you're going to do is called masses and springs. So when you click on the icon and you get to this picture here, click on the play button, go to intro, all right, and here's where you're going to collect some data. You're going to use a couple of tools. You're going to go to the upper right hand corner and you're going to click on natural length and movable line. Not equilibrium position might help you as well, but let's take our movable line, put that there. Then you're going to take and bring out your ruler. All right, so you want to take and line up your ruler to the bottom of the structure that it's hanging from, all right, and to the equilibrium line, or the natural length, sorry, the natural length where is the bottom of the spring. And you're going to give that measurement, okay? So you have, you can measure this to centimeters. Assume this is centimeters, so you'll do 4 point, looks like it's between the 7 and the 8, I'm not sure. And then, of course, you want to read in between the lines, all right? And that will give you the right number of significant digits. Now, your data table has it in meters. We're going to assume this is centimeters, so your answer will be something like 0.047 and then read in between the lines, or 0.048 and read in between the lines. The next thing you're going to do is you can move your ruler to the side a little bit, grab the 50 gram, okay, the 50 gram mass, all right, and you're going to slowly let it just hang. You don't want it to bounce, okay? So bouncing is not good. So if it's bouncing, click on slow, all right? And then how do you make it not bounce? So let's see, it's going down to 84 up to about 42. So somewhere in the middle is where it won't bounce. Somewhere right in between 44 and 80. So let's try maybe 62, unless that equilibrium position is the right position. Let's try that green line here. All right. We'll go to the green line. That makes it real easy here. So your next recording that you're going to take will be your stretched length. So this is equilibrium down to where the 50 kilogram mass stretches it. I'm sorry, not kilogram, 50 gram mass. So you're going to do 0.05, 6 or 7, and then read in between those lines and record the stretched spring mass. Then you can take your 50 gram mass and pull that off. See here, there we go. And put on the next mass, which is the 100. There's 200s, just use one of them. We only need one for this lab. Okay, and it looks like the green line popped right down to where your equilibrium position is. So you look out there. So you got 0.064, maybe 0.0649, maybe something like that. So you write down your estimate. All right, and then pull that off. Then do the 250, and you should get a green line possibly. There it is. All right, so you want to rest the mass there. That's just called the resting place, the resting mass right there. Give a recording for the mass, put that one back. Now on this side, you have masses that are not known. So take the pink one, all right, and find the equilibrium position, and then put that down as your stretch spring length, all right, and then do the same for the teal one here, the tan one, the larger tan one. And so what you're going to do is record all that data in your data table over here, all right, your data table, right, so you have the spring mass. Okay, record that in kilograms because you're going to be using gravity and converting it to force. So you want kilograms, so your 50 gram mass will be 0.050 kilograms, and so on. You don't know the mass of the pink, the teal, and the tan, so we'll just leave the mass of each of those blank. The initial spring length should be the same, right, for each one of them. And then, of course, the stretched spring length will be different for each one of those. After you record your data from the online lab, you're going to go to, let's see, where is it at? Professor Anderson is going to explain how to calculate what you're going to put in the next part of your data table, okay? He's going to show you how to calculate the elongation or the stretch. That's pretty easy, right? So you're just going to subtract the stretched length minus the initial spring length for each of these, and you can record your elongation. Professor Anderson is going to show you how to calculate the spring constant. So he'll derive a formula from a formula you already know, all right? And you'll calculate the spring constant. And then from the formula that you already know and the one that he shows you, you're going to calculate the mass of the pink, the teal, and the tan, all right? That formula is not given in his video. If you are having problems deriving a formula or solving for just the mass, then go ahead and Zoom me, but it seems like it'll be pretty simple. The last part, you're going to go into graphical on your iPad and type in your data, spring force, which will be calculated in newtons. So you have mass, you'll have to multiply that times 9.8 and make it the force for your y-axis, and the elongation, so how much it stretched, so this column here. All right, if you have any questions, please feel free to contact me. Thank you.